Hello everyone, welcome back to Mr. A's Geometry Podcast. This is the first podcast of 2009, so Happy New Year. What I thought we'd take a look at today is mean proportionals in a right triangle. Now, this has to do with this picture here, where we have one large right triangle, and then what we do is we drop an altitude from the vertex down to the hypotenuse. Remember, an altitude is a line drawn from the vertex of a triangle that's perpendicular to the opposite side. So in a right triangle, if we make an altitude to the hypotenuse, it's perpendicular, which means we have two smaller right triangles within the picture. And when this happens, we get these series of similar triangles. If you're in my class, then we prove that the big triangle is similar to the one on the left and the one on the right, which means that the two smaller triangles are also similar. So we can set up some proportions here using the properties of similar triangles. The two main proportions we use are these two here. This first proportion tells us that a leg of the main triangle, that is to say, one of the legs of the big right triangle, is the mean proportional between the hypotenuse and the projection of that leg. So, mean proportional is bottom left, top right, between the hypotenuse and the projection of the leg. The other formula that we have is that the altitude of the main triangle is the mean proportional between the two segments or the two projections. That would be this piece here, P leg A, and this piece here, P leg B. By the way, if you're any confused about why we call them projections, think about shining a flashlight straight down from above onto this figure. If you had a flashlight and shine straight down this way, where's the shadow for leg B going to go? Well, it's going to end up right here at P leg B. And if you shine a flashlight straight down over leg A, where's that shadow going to be? Well, leg A is going to be right here on P leg A. So that's why we call them projections. And it turns out that the altitude is the mean proportional between those two projections, P leg A and P leg B. So let's look at how we do a problem with these. This is a fairly typical one. You'll be given a few pieces and asked to find a third. Here we have AD is 4, AB 13. We want CD. So in order to figure this out, we're going to have to label our picture. I've already got mine. You should draw yours. I have AD is 4, so I'll put that over here. AB is 13. Well, that's this whole piece here, 13. And CD is what I'm looking for, the altitude. So I'll call that X. Now the first decision you need to make is which one of these two proportions are you going to use? There's a very easy way to figure this out. You're going to look at the problem and just ask yourself, do I have an altitude in this problem? Either you're given an altitude or you're asked to find an altitude. If that's the case, this is your guy right here. You'll notice that the altitude does not exist here. So if you want altitude, you've got to go with this one. And conversely, if you do not have an altitude and are not asked to find an altitude, you're going to go with the top equation. Height over leg is leg over P leg. So in this problem, do we have an altitude? Sure. So we're going to go with this proportion on the bottom. So we need to know what P leg, altitude, and P leg B are. Well, P leg A, that's 4, no problem. Altitude, that's what we're looking for, that's X. P leg B, we're not given P leg B, but you can figure it out, right? If this whole thing is 13, and this is 4, then that's 13 minus 4, or 9. So we've got 9 for our P leg B. Well, now we just plug into the proportion and solve. So we're using here P leg A, that's 4, over altitude, X, equals altitude over P leg B. That's 9. All you're doing is plugging in your values. Cross multiply here, product of the means equals the product of the extremes. You have x squared equal to 36. Take the square root of both sides. And x is 6. So in this problem, our altitude is 6. Okay, so here's another mean proportional problem. It's all set up for us. This time they're telling us AB is 2, DB 16. We're looking for CB. So let's go ahead and label our picture. If AD is 2, DB is 16, CB is what I'm looking for. So remember, the first thing you want to ask yourself, am I going to use altitude here? Well, do you see an altitude? No. Are we looking for an altitude? No. So which proportion are we going to use? The one without the altitude. Height over leg is leg over p leg. So do we have what we need? Well, hypotenuse. Conspicuously absent. Easy to find though, right? 2 plus 16, 18 is your hypotenuse. So this whole thing is going to be 18. Hypotenuse over leg. So 18 over, that's our leg, x. That's what we're looking for. That has to be equal to x over the leg over its projection. Now remember, projection is just if you shine the light down. So if you shine a light down above this side, is it going to cast a shadow here or over here? Over here. So 16 is the projection of x. So 18 over x is x over 16. Right? Now we cross multiply. So here we get x squared equal to 18 times 16. Well, that's kind of a big number. If you use a calculator, I believe that comes out to 288. Let me just double check. So we go to 288 here. And then you need to simplify. Well, we take the square root of both sides. X is equal to radical 288. That's kind of a big perfect square, but not to worry. You need to find the largest perfect square that goes into 288. Should be able to handle that, right? The largest perfect square that goes into 288, how about 144? X is radical 144 times radical 2. That's the square root of 12. Or excuse me, that is 12, the square root of 144. So x is 12 times radical 2. That's all you got. Plug that back in. That's your answer. X, 12 rad 2. Right. Next, we're going to look at one that's a little bit more interesting. You have to play with and come up with a variable. So give me a second. Cue that up. Okay, so this is the one we're going to finish with. Mean proportional that's going to really tie everything together. In this problem, we're told that the altitude is 14, that the ratio of the segments, remember, segments is another way to refer to these projections, right? Because the altitude splits the hypotenuse into two segments. So the ratio of the segments, which means our two projections, is 1 to 4. This is two-part. We have to find the segments, the two projections, and then we have to find the legs, AC and CB. So this is going to take a little bit of work. We'll start with part A, find the segments. Well, we should label our picture before we do anything. Altitude is 14, so that goes up here. Now, how am I going to label these segments? If they're in the ratio of 1 to 4, then we have to respect that, but we don't know exactly how large they are. So you might think, well, maybe I can say this one is 1 and that one is 4. If you do that, they'd be in the proper ratio, 1 to 4. But do we know that this is 1 and this is 4? That's going a little bit too far. So the way we fix this is instead of calling them 1 and 4, we use a variable. We say, I don't know how big this is, but it's 1 times something. And I don't know how big this is, but it's 4 times the same thing. 1x and 4x is how we deal with this 1 to 4 ratio. So our first task is to find the segments. Well, if we want to know what the segments are, we know what the altitude is. That means which proportion are we going to use? The one with the altitude. So let's set it up. It shouldn't be too hard. P leg A, that's 1x, or just x, over the altitude is equal to the altitude over P leg B. That's 4x. Okay, so here we're going to cross multiply. Product of the means equals product of the extremes. We have 4x squared equal to 14 times 14. 14 times 10 is 140. 4 times 14 is another 40 plus 16. That's 56. 140 and 56 is 196. Okay. Now we have an x squared here, so we're going to want to take a square root. But before we do, let's divide by 4 on both sides. Get this x alone. So if we divide by 4, both sides, now we have x squared equals 196 over 4. Well, what's that? X squared equals 49. You can check that on your calculator. So if x squared is 49, then it's pretty simple. X has to be 7. All right. So if x is 7, now we go back to our original picture. This is 1x, this is 4x. So now I can update my picture a little bit. Instead of 1x, I can now write 7. And instead of 4x, I can now write 28. So that's part A, find the segments, 7 and 28. Now we have to go to part B. So let me just get rid of a little bit of board space here. And in fact, I'm going to go ahead and erase this so we have a little bit of room to work. What we're looking for are the 2 legs. So before I erase that, let's just put that up on our picture. I want to find both legs, this one and this one. Well, if I was only looking for one, let's say it said to find AC, what would I do? I put a big old X by AC because that's what I'm looking for. But I'm also looking for CB. So can I call CBX? If you do call CBX, what are you assuming? You're assuming that AC and CB are the same, that they're congruent. We don't know that, so we can't call this X, let's call it Y. Okay. So our job now is to find X and find Y. So I'm going to erase this just to get a little bit of space here. Okay, well let's take X first. Find X. If we're looking for X, what part of the triangle is X? It's a leg of the large triangle. So we have to work with this top proportion. There is no leg here. We have projections of legs, but not legs. So we're going to work in this top proportion here. We're going to say hypotenuse. What is my hypotenuse? This whole thing here, 7 plus 28. 35. So hypotenuse, 35, over leg. Well, the leg is what I'm looking for, X, equals leg again, so X, over P leg. So who is the projection of X? Is it 7 or 28? If you shine a light down on X, I hope you can see it's going to be right here, AD. So the P leg, the projection, is 7. So, okay, product of the means equals product of the extremes. So in this case, when we cross multiply, we have X squared equal to 7 times 35. Well, 7 times 3 is 21. So 7 times 30 is 210. 7 times 5 is 35. So we've got 210 plus 35, 245. But that's X squared. We need to find X, so we're going to take the square root of both sides. X over here. We need the largest perfect square that goes into 245. So you should make your list across the top of the page, right? 4, 9, 16, etc. And if you play with the calculator a little bit, you should come up with 49. And it turns out that 49 goes into 245 5 times. So we can break this up as rad 49 times rad 5. And of course the square root of 49 is 7. So we have X equal to 7 rad 5. That's our X. Okay, so find X, check, we did that. Let's go find Y now. So I'll do Y in green. Find Y. Well, Y is essentially the same, right? It is still a leg, so we're going to use the same proportion. Hyp over leg equals leg over P leg. Hypotenuse is 35 over Y is equal to Y over the projection of Y is 28. Oh my. Okay, product of the means equals product of the extremes. This gives us Y squared equal to, okay, 35 times 28, that's kind of big. Well, 28 is close to 30. So let's do 35 times 30 and then we'll take 2 of them away. 35 times 30, well, 3 times 3 is 9. So 30 times 30 is 900. Plus I have to add 5 more 30s. 5 30s is 150. So I have 900 plus 150, that's 1050. But I can take away 2 35s. So 2 35s is 70. 1050 minus 70, that's 980. You can play around with your calculator a little bit to find the largest perfect square that goes into 980. This one I'm just going to take a little bit of a shortcut or a long cut depending on how you think about it. I know that 4 goes into this number. 4 goes into 100, 4 goes into 80. So if I take the square root of both sides here, I get y is equal to, and I can replace radical 980 with radical 4 times, works out to be radical 245. This is actually nice because we figured out rad 245 over here. It's 7 rad 5. That means y is 2 times 7 rad 5, right? Square root of 4 is 2. Square root of 245 is 7 rad 5. We did that over here, which means y is 14 rad 5. And there you have it. So the key with these mean proportionals is, well, first of all, you need to know the picture and what everything is called. And you need to know these two proportions. They're very easy if you just remember that. The leg is the mean proportional to the hypotenuse and its projection, and that the altitude is the mean proportional between the two segments or the two projections, however you want to remember it. Set your problem up, draw a picture, label it. If you have an altitude, this is your guy. No altitude, that's your guy. Plug in and solve. You might have to simplify a radical. You may have to factor a trinomial. But in the end, it's really just product of the means equal product of the extremes, and you work it out. That's algebra. So, thanks for watching. I hope you enjoyed and that this helped you. If you have any questions, please ask me in class or send me an email if you're not one of my students. And as always, thanks for watching. Have a great night.